Hi everyone in Algebra 3. Today we're going to be going through your questions that you have on lesson 60. And we're going to start on number 1. So for number 1, it says how many ways can the letters in the word came be arranged if a constant is in the 4th position? So for number 1, I'm going to start with 4 boxes because I have 4 letters in the word came. I'm only using the letters in the word came, which means that it's going to be non-repetition. So that means that this has to be a consonant. So of the letters in the word came, 2 of them are consonants. So I always have to start with the place that has the most conditions, which would be this one. So I have 2 consonants that I'm choosing from. Once I've used one of them, I'm going to cross them out. Now I have 3 left to fill the first spot. Then I used one of them. Then I have 2, and then I have 1. So altogether, I would have 12 different ways I can rearrange these letters so that the consonant ends the letters being rearranged. So it'd have to end with either C or M. And then you use the rest of the letters to fill in the other spaces. And you reduce it by 1 every time because we're not going to be doubling up on those letters. Moving on to number 2. So number 2 says how many distinguishable ways can a host and 10 guests be seated in a row if 3 of the guests are identical triplets? All right, so this problem's a little bit silly because for distinguishable permutations, it's the total number of people divided by the number that are alike. And they're saying basically that these identical triplets, you couldn't tell the difference between them. So they count as, well, we're taking them away as being doubles. So we have a host and 10 guests, which means that we have 11 total people. And then we have identical triplets, so that would be 3 factorial. So it's 11 factorial divided by the number that are like factorial, is taking them out of the equation basically. So that would be 11 factorial divided by 6. And your answer would be 6, 6, 5, 2, 8, 0, 0. Okay, and that concludes number 2. Moving on, we're going to look at number 3. So for number 3, it says the angular velocity of the wheels on the fire engine was 367 radians per minute. If the radius of the wheels was 16 inches, what was the linear velocity of the fire engine in miles per hour? Well, I remember that the equation for linear velocity is velocity times angular velocity times radius. So I know that the angular velocity is 367 radians per minute. And my radius is 16 inches. Now I'm not going to use radian because all I want to do is get this from inches to miles and then from minutes to hours. Remember, radian is the one you can cross in or add in as needed. So now I'm going to convert this from inches to miles. So I'm going to start with converting this to feet. So that would be 1 foot, 12 inches. And then 1 mile, 5,280 feet. So you should see that the feet cancel and the inches cancel. Now I just need to get this from minutes to hours. So 60 minutes over 1 hour, and my minutes will cancel. So your answer rewritten is going to be 367 times 16 times 60 divided by 12 times 5,280. And that is going to be in miles per hour. Okay, so linear velocity is equal to angular velocity multiplied by the radius. Moving on to number 4. Number 4 is a similar problem. This one's the linear velocity of the go-kart was 5 kilometers per hour, but its wheels were only 10 centimeters in diameter. What was the angular velocity of the wheels in radians per minute? Okay, so I am going to be going 5 kilometers, 10 centimeters. Okay, so the equation you start with for number 4 is linear velocity is equal to angular velocity times radius. I'm trying to get the angular velocity by itself, so I'm multiplying both sides by 1 over the radius. So my angular velocity is going to be equal to the linear velocity, which is 5 kilometers per hour. And that's being multiplied by 1 over the radius. And the diameter is 10 centimeters, which means that the radius is 5 centimeters. Now I'm going to convert from centimeters to kilometers. So I know there's 100 centimeters in 1 meter, cancels out the centimeters. And then I know there's 1,000 meters in 1 kilometer. And if you see, that cancels out the meters, but it also cancels out the kilometers. And then I'm going to go 1 hour is 60 minutes. So the hours cancel. You should also see that the 5s could cancel too. And there's no longer a unit of measurement. So my answer is going to be 100 times 1,000 over 60. And remember that you can add radians as needed. So it would be radians per minute because I no longer have a unit of measurement. Now moving on to number 14. So number 14 is going to be one of our longer problems because we're trying to find the distance between a point and a line. The distance between a point and a line. So we have -4, 6, and then y is equal to x plus 2. So the first thing that you're going to do for number 14, the first step is to find the perpendicular line of this line that goes through that point. The perpendicular line that goes to that point. So perpendicular and goes through -4, 6. So that means if I flip that, it's going to be y equals -x plus b. And then I'm going to plug in my points. So that would be 6 equals -4 plus b. So my b would be equal to 2. So my perpendicular line that goes through -4, 6 is going to be y equals -x plus 2. Now what we're going to do is we're going to solve for where this line, the original line, and my perpendicular line intersect. So the way you do that is by setting them equal to each other. So I'm going to set my original x plus 2 equal to -x plus 2. Well, you'll see that the 2's are going to cancel. And when I bring the -x over, that would give me 2x is equal to 0, which means that my x coordinate at where they're going to intersect is going to be equal to 0. Then we're going to solve for where it intersects on the y coordinate. So I'm going to plug this 0 into the original line. That would be y is equal to 0 plus 2. You could have also plugged it into the perpendicular line. It doesn't matter, which means that my y is going to be equal to 2. And my last step is to use the distance formula, which is the square root of x1 minus x2 squared plus y1 minus y2 squared. So my x1 is going to be, I'm going to use the -4 minus x2, which is 0. My y1 is going to be 6 minus my y2, which is 2. So I'm left with -4 squared plus 4 squared. So 16 plus 16 would be 32. the square root of 32 can be simplified to 4 square root 2. And that would be your distance. Okay, so it's a 4-step problem. You do have to memorize all 4 steps in order for you to be able to finish that problem. Now moving on to number 15. So for number 15, we are graphing a parabola. So the first thing that we're going to do is we're going to put all the x's in parentheses. Leave a space, and then on the outside would be +0. So I'm just putting that there so I can remind myself that I am going to need to do something to the outside. Before I can complete the square, I have to factor out a 3. Now when I take half the term that's attached to x, half of 2 is 1. But when I square 1, it's still 1. But don't forget that this is actually +3. So on the outside, you do the opposite. So if I add 3 on the right side, or if I add 3, then I'm going to subtract 3 from the outside. Now this is going to be, or this is positive, so this tells me it's going to be a happy face parabola. It's going to face up. The x plus 1 is my axis of symmetry, so I set that equal to 0. X would be equal to -1. And this right here is my vertex. Now this 3 though, on my chart, this chart right here, I usually go over 1, up 1, over 2, up 4, 3, and 9. But now what I'm going to do is I'm actually going to multiply those values, the y values, by 3. So that means 1 times 3 is 3, 3 times 4 is 12, 3 times 9 is 27. And that will alter how narrow the parabola is going to be. So now I'm going to graph this. And my axis is -1 and then -3. Okay, so now my axis of symmetry is at -1. So this is going to be right about here. Now mine's not going to be perfect because I don't have lines on my paper. And then the vertex is at -3, so down 3. Now from that point, I'm going to go over 1, up 3. So over 1, up 1, 2, 3. Over 1, up 1, 2, 3. And then if you go again, it would be over 2, 1, 2, up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that would be the same here. So notice that the larger the number, the more skinny your parabola is going to become. So I'm going to connect these dots, and it should be a very skinny parabola that looks like this. Or something like it, because mine is a little bit wonky. And that concludes number 15, so how you do your parabola. So whatever number you factor out is what you multiply by your y values, and that will determine how narrow or wide your parabola is going to be. Now moving on, we're looking at number 17. So for number 17, we're looking at this diagram right here. We are writing this in terms of a cosine function. So we kind of it's already in a cosine function. So, and it's a positive cosine function. So I have my equation y is equal to a plus b cosine c theta minus d. I'm not going to have this minus d because it's already a cosine function. To solve for a, you're going to find the midpoint between the top and the bottom number. So it'd be 10 plus -30 divided by 2. So 10 plus -30 would be -20, divided by 2 would be -10. B is the distance between this top point and that -10. So you're going to do top minus whatever that middle value was. So that would be 10 plus 10, which is 20. Now C is your coefficient. And that this is going to be in radians, so it's going to be 2 pi divided by the length of the period. Now, the way you calculate the length of the period can either be from peak to peak, base to base, or one full rotation. So I'm going to start by saying that this peaks at 0, and then it peaks again at pi. So that's 1 period length. So that means that I would be doing 2 pi divided by pi. Now my pi's are going to cancel. So my coefficient is going to be 2. And my result is going to be y is equal to a, which is -10, plus b, which is 20, cosine c, which is 2 of x. Again, there's no phase shift because it doesn't have to move. It's already in a cosine function, which is what they wanted. And that was just number 17. Now moving on, we're going to look at number 21. Actually, number 20, and then number 21. So number 20 is the central angle of a sector of a circle is 80 degrees. Find the area of the sector if the radius is 20 centimeters. So the area of a sector, the formula, when it's in degrees, is x degrees over 360 times pi r squared. Now my x degrees is the central angle, so that would be 80 degrees over 360 times pi times my radius, which is 20 squared. And now you just need to multiply that through. So that would be 80 times pi times 400 divided by 360 gives us an area of 279.25 centimeters squared. It's the area of a sector. And that does differ from finding the area of the segment, which we are asked to do in number 21. It says find the area in square feet of the segment bounded by an arc of 2.4 radian and the chord which joins the endpoints of the arc in a circle of radius 10 inches. All right, so what I'm going to do first is I'm going to start, well, we need to change this into feet. So I'm going to change my radius from 10 inches to feet because it says we want the area in square feet. So that would be 1 foot, 12 inches. So 10 divided by 12 is going to give me, 0.833 feet because the inches cancel. Now, the area of the segment equation in radians is going to be x over 2 pi times pi r squared minus r times r sine of x divided by 2. Now, my x is going to be 2.4, and that would be 2 pi times 0.833 squared minus 0.833 times 0.833 sine of 2.4 divided by 2. Now, the one thing you have to remember is that when we're doing sine of 2.4 radians is that you actually need to change in your calculator from DEG to RAD. So the way you change that in your calculator is next to the second button to the right of it. If you press it once, it should say RAD at the top. And that means it's in radians now. So I'm going to start by calculating this portion. So I have 0.833 squared times 2.4 and then divided by 2. And I'm going to use a lot of those decimal places just because it's such a small number. So I'm going to use 4 decimal places. So 0.8327. Then I'm going to do the second part. So I'm going to do a sine of 2.4. So I already put it into radians. So it'd be 2.4 sine times 0.833 times 0.833, then divided by 2. And again, I'm going to just write it to 2 decimal places. So 0.2343. And that we're subtracting from 0.8327. And that gives me a difference of, and I'm going to put this in to round this 2 decimal places, which actually rounds to 0.6. And that's feet squared. And then I would always change my calculator back into degrees just so you don't forget, which means you press this DRG button twice and it should get you back into degrees. So it's kind of the same thing that we've been doing for the area of the segment bounded by an arc. We just have to change your calculator from degrees into radians. So make sure you're doing that. Now we're going to move on to number 25. Nope, number 23. So for the first thing that we're going to do for this one is I'm going to move the 1 to the other side. So I have, for number 23, I'm going to have sine of 3 theta is equal to 1. Now, this is going to require us to use a unit circle because I don't have a reference triangle that has an opposite of 1 and a hypotenuse of 1. So I'm going to create my unit circle. And I need to remember, what am I looking for on this? Well, sine is equal to the y coordinate. So I'm looking for at what degree is the y coordinate equal to 1? The y coordinate equal to 1. So if I underline all my y coordinates, I notice that there's only one place where the y coordinate is equal to 1, and that's at 90 degrees. So I'm going to say 3 theta is equal to 90 degrees. Now, when I divide both sides by 3, because of that 3 that's attached to theta, I'm going to get theta is equal to 30 degrees. But remember, we don't need just one answer. We actually need 3 answers. So I'm going to set 3 theta equal to 360. Divide that by 3, and you get 120 degrees. Now, this is going to be what you're going to continuously add until you end up with your 3 answers. So 120 plus 30 would be 150. 150 plus 120 would be 270. And those would be your 3 answers. So 120 ends up basically being the difference between all of these variables. And that concludes number 23. Moving on, we're going to look at number 25, which has lots of different problems. But for this first one, I have the arc sine of pi over 4. So for number 25, A, we have arc sine of the sine of pi over 4. Well, pi over 4 is a 45-degree triangle in quadrant 1. So if I draw that, 1 root 2. The sine of this would be opposite over hypotenuse, which would be arc sine of 1 over root 2. But now I have to solve for the degree. I already solved for the degree because the degree is just going to be pi over 4. The radian is just going to be pi over 4. So really, the arc sine and the sine kind of, because they're the same, and because this is in quadrant 1, the first place where sine is positive, it just works out that those kind of cancel each other out, and then you're just left with pi over 4. Now for the second one, for number part B, we have cosine squared of arc sine of negative 1 over 4. So I'm going to start by drawing my triangle for arc sine of negative 1 over 4. Sine is opposite over hypotenuse. If all students take calculus, we don't use quadrant 3 sign is positive in 1 and 2, which means the only place where it's negative would be quadrant 4. So I'm going to draw a triangle in quadrant 4, label my sides opposite, -1, hypotenuse of 4. Now I have to find my length of my adjacent side by doing Pythagorean theorem. So I'm going to do x squared plus 1 squared equals 4 squared. So subtract 1, so 16 minus 1 is 15, so I have x squared equals 15, which means that this is going to be the square root of 15. Now the cosine of that triangle is adjacent over hypotenuse. So I'm going to have, my answer is going to be root 15 over 4. But don't forget, because it says that we have to square that ratio. So my result will be 15 over 16. And that will be for part B. And then finally for part C, I have 3 pi over 4. So I'm going to start with creating my snowflake chart. So 1, 2, 3, 4, 5, 6, 7, 8. Starting at 0, counting 3 would be 1, 2, and 3. That puts us in quadrant 2. Because the denominator is 4, I know it's a 45-degree triangle. So this would be -1, 1, and root 2. I'm going to start with sine. So sine is opposite over hypotenuse. So that would be 1 over root 2. But don't forget that you're going to square that. That's why I'm not moving the square root to the numerator. Then minus, and this would be adjacent over hypotenuse, which would be -1 over root 2. And then you have to square that as well. When you square 1 over root 2, you get 1/2. Square 1 over root 2 would be 1/2. So 1/2 minus 1/2 would be 0. And that would conclude number 25. Moving on to number 27. So for number 27, we're trying to write the quadratic equation with a lead coefficient of 1, whose roots are -1 minus root 3i and -1 plus, well, that should be root 3i, I think. Yeah, should be square root of 3i. And the way you do this problem is you're going to start with x minus root times x minus root equals 0. In the end, you want an equation that's ax squared plus bx plus c. Okay, so I'm going to start by plugging in my roots. Remember that when you plug in your roots, the signs are going to change. So these two negative signs are going to change to a positive. So that would be x plus 1 plus root 3i. And then switch the signs again. So x plus 1 minus root 3i. Now you're going to multiply this out. So x times x is going to give me x squared. X times 1 is x. X times negative root 3. So that's, sorry, that should be negative root 3i. X, 1 times x would be x. 1 times 1 would be 1. 1 times negative root 3i would be negative root 3i. Root 3i times x would be square root of 3i. X, square root of 3i times 1 would be square root of 3i. And then square root of 3i times negative square root of 3i. Well, square root of 3 times negative square root of 3 would be negative 3. But I times I would be negative 1. So it would be negative 3 times negative 1. I should see that my negative root 3i and my root 3i would cancel, and my negative root 3ix and positive root 3ix, which means I can combine my x's, I can combine my 1 and my 3. So I would be left with x squared plus 2x plus 1 plus 3 would be 4 equals 0. And that would be my answer. So flip your signs of your roots when you're plugging it in, and then distribute, and then simplify. Moving on to number 28. Number 28, we are trying to determine if these are inverse functions by computing their composition. So I'm starting with f of x equal to 5x plus 4 over 2x minus 7. And then g of x is 7x plus 4 over 2x minus 5. So I'm going to start on number 28 by computing f composite g of x. Now remember that both composites have to be equal to x in order for them to be inverse functions. I know what my g of x function is equal to. It's 7x plus 4 over 2x minus 5. So this would become f of 7x plus 4 over 2x minus 5. And I'm going to plug this into the f function. So wherever I see an x, I replace it with this entire function, which makes it quite complicated. So it's going to be 5 times 7x plus 4 over 2x minus 5 plus 4 over 2 times 7x plus 4 over 2x minus 5 minus 7. So I replace this x and this x with this entire function. Now I'm going to make a common denominator while also distributing. So my common denominator is obviously 2x minus 5. So if I distribute the 5, I have 35x plus 20. 4 times 2x would be 8x. 4 times negative 5 would be minus 20 all over 2x minus 5 over 2 times 7 would be 14x. 2 times 4 would be 8. Negative 7 times 2x would be negative 14x. Negative 7 times negative 5 would be plus 35 all over 2x minus 5. Now I can cancel out the 14x's in the denominator, cancel out the 20's, which would leave me with 35 plus 8, which is 43. So it would be 43x over 2x minus 5 over 43 over 2x minus 5. Now multiply both sides, or top and bottom, by the reciprocal of the denominator, which would be 2x minus 5 over 43. You should see 2x minus 5's cancel and the 43 cancels. You are left with the result of just x. Unfortunately, that does mean that we're going to have to go through and do g composite f of x to make sure they're both equal to x. I know what my f function is equal to. It's equal to 5x plus 4 over 2x minus 7. I'm going to do a very similar thing to what I did. So this one's your, this is your f1. Then I need to now do the g composite f, which means I take this function and replace all my x's. So it'll be 7 times this plus 4 divided by 2 times this minus 5. So 7 times 5x plus 4 over 2x minus 7 plus 4 over 2 times 5x plus 4 over 2x minus 7 minus 5. Again, common denominator of 2x minus 7. And now I'm going to distribute. So 7 times 5 would be 35x plus 28. Distribute the 4. 8x minus 28 over 2x minus 7 over, now distribute the 2. So that would be 10x plus 8, distribute the negative 5, negative 10x plus 35 over 2x minus 7. You should see that the 28 cancels, the 10x cancels. You're left with 43x over 2x minus 7 in the numerator. And the denominator, you end up with 43 over 2x minus 7. Just like on the last one, you're going to multiply by the reciprocal of the denominator, which is 2x minus 7 over 43. The 2x minus 7s cancel, 43s cancel, you are left with just x. So all of that work tells you that yes, they are inverse functions of each other because both of the inverses or the compositions are equal to x. And then finally, we are on number 30. And for this one, I'm going to use different colors to represent each of these pieces. So I have f of x plus h going to be represented in red, minus, and then over 2h is going to be represented in black, and then f of x minus h is going to be represented in green. So now I'm going to start with plugging in this x plus h into the f function, meaning that you're going to place all the x's with x plus h. That means that I would end up with, for my red function, x plus h times x plus h plus 3. I replace the x with x plus h, this x with x plus h, and that's what you get for your f function, or for your red function. Now for green, same thing, but you're replacing these x's with x minus h, so it would be x minus h times x minus h plus 3. So replace this x with x minus h, this x with x minus h. That's all going to be over 2h. Now you do need to multiply this out. So x times x gives you x squared. X times h gives you xh. X times 3 gives you 3x. Then h times x gives you xh. H times h gives you h squared. Then 3 times h gives you 3h. That's your whole red function minus your whole green function. So x times x gives you x squared. X times negative h would be negative xh. And then x times 3 would be 3x. Then negative h times x would be negative xh. Negative h times negative h would be plus h squared. And then negative h times positive 3 would be negative 3. Yikes. H, and that's in parentheses. And that's all going to be over 2h. Well, now it's just combining. So what I'm going to do is I'm going to start by just distributing the minus sign, leaving everything in this function the same. So x squared plus xh plus 3x plus xh plus h squared plus 3h minus x squared plus xh minus 3x plus xh minus h squared plus 3h all over 2h. Now I could have combined things and I didn't. So now I'm going to combine things and cancel things. So my h squareds should cancel. I have my 3x and my negative 3x. I have an x squared and a negative x squared. Now I can add the xh's, which I should have 4 of them. So that would be 4xh. And then I have my 3h and 3h, which would be 6h. Now you should see in the numerator you can factor out a 2 and an h, which would leave you with 2x plus 3 over 2h. Now your 2h's cancel, and you're left with 2x plus 3. And that is your result. And that concludes all of your questions on this lesson 60. Hope you guys all have a great day. Bye.